Am I here? Is it working? Is audio on? Maybe this has worked. Okay. So, if that actually worked, I am shocked because this entire streaming setup I totally rebuilt yesterday. Okay. So, somebody please tell me if it worked. Okay. Amanda, thanks. Yes, we are live. Oh, hang on, but what I don't have is TTS. That's what I forgot to open. So here it goes. Hang on. Oh, hopefully I'll get this in time for Johnny's thing to come up. Logging in. Let's see. Quick. Opening. Yes, hopefully the TTS will catch up. Do I have audio on? I do. All right. We should get there, people. Okay. Good time zone, yes. Good time zone, Johnny.
Austin's_creation said, "We are live."
We are live. That one is for Johnny. Thank you. I just got a message from Lachlan saying on the gas meter, that is a squirrel. He has just put a squirrel on the gas meter, which is right outside my front door. So I might go and grab that in a second, because I'm going to have a couple of squirrels to talk about before we get into the thing. So TTS is currently working on populating its list. It's catching up. Yeah, so for years now, I have been using my old 2009 MacBook Pro Retina as my streaming control device. It's been running, that's had OBS running on it. It's had Companion running on it. My Stream Deck has been connected to it. It's been sending commands to the 8M, and then that has been capturing...
Amanda Thompson said, "See, you have the SuperHouse sign up again."
Yes, that's one of the squirrels. So the... yeah, it was all controlled through my Retina MacBook Pro.
Said, "No barbecue today, folks. It is next week."
Yes, that's right. Thanks, Austin, for pointing that out. Just in case there is someone on the stream who was thinking of turning up at my door today. I can't, because I'm going to have to be having lunch with my mum and my sister. So, the 2009 Retina MacBook Pro went out of security updates a while... Okay, hang on. Before I totally distract myself, I have got to do the important thing. I acknowledge the traditional owners of this land, the Whadjuk Noongar peoples. I pay my respects to their elders, past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. Okay, so it got to a situation where the computer was so old that it was multiple releases of macOS out of date, which meant that software could not be updated. I couldn't run the latest OBS, couldn't run the latest Companion, couldn't run a whole bunch of things, and it just became unworkable. It was becoming a problem. So what I have done is I now have
Amanda
OBS.
Thompson said, "Happy Mother's Day."
Yes, happy Mother's Day, Amanda, and to everybody else out there that applies to. So I'm now running OBS on my Mac Mini, and I'm running an updated Companion, which is running as a Stream Deck plugin. I've reconfigured all of the scripts, all the control system. It's all like set up from scratch. So the fact that that worked and I went live when I pressed that button is kind of a miracle. Yeah. So where are we? All right. Some very quick good mornings to Crispian, Imi, Austin, Tabraze, Amanda, some call it fun, Jordan, Gavin Jackson, Stephen W, John Whips, Henrik, welcome Henrik, Sharky, Stephen George, Matt W, David Howes, Tassie Bob, thanks for coming along. Thanks for doing the big swim. Hang on, I just accidentally clicked someone off the list. Who was it? Some call it fun, I think. Andrew Ruthven, Samuel Kimani, Mark Laguda, Grant Mazels is here. Grant, Eddie Mules, Scott Miller, Cassio. Thank you all for coming along. Okay, I have got, oh, and Paul Schultz is here. I just saw in the chat, not in the list yet. The list will update momentarily. So, in a second, I will go and grab the squirrel that Lachlan left sitting on top of the gas meter. And in the meantime, okay, here we go. This is going to be the first view transition triggered by the Stream Deck running as a companion plugin to the thing. Let's see if this works. Oh, that was a message from my sister. Cool. No worries. That was just about lunch arrangements. Here we go. Let's see if this works. Pressing the button. It worked. We did an input source change on the ATEM. Nice. So, okay. This is just a quick thing that I came across during the week and I thought it was really cool. So I wanted to show this. It might be useful for people. So what you've probably seen are on microcontroller boards and different things, pinout diagrams that have got labels against the pins. I normally do this using Keynote. Many people do it using PowerPoint, presentations of a software. Those are generally good tools for doing this sort of diagram, or you can do them in Inkscape or whatever. But this is a little generator for it. So what you can do, I'm just going to go back from there. No, back a few. So this is, in fact, what I'm going to do is chuck this in the chat. Pinout leaf generator. I'm going to chuck a blog post about it in the chat. So what this does is allow you to configure, basically what you do is you load a picture of your board, whatever it happens to be, and you then define what the pins and things are with spacings and types. So I'm going to go back to one of the examples. So this is one of the examples. And you can configure it on the right using this text thing. So what we've got is the sources for the front and back images. We've got number of pins counted in the title and some types. I think that's it. Like that is the total of the, is there any scale? Oh, excuse me. Any scaling? Yeah, I'm not quite sure how the scaling works. So I haven't used this myself other than messing around with this example, but I figured that people might find this useful. So if you're wanting to do diagrams of things, and what you can do, for example, is if we wanted to change this pin name, so see up here on the top left, we've got EN for enable, and down here we've got EN in green for enable. So let's just change that label to enable. And you can see that it just regenerated this image here. So click the images to download. So we could just click that and download it, or you could screenshot it if you wanted to. But yeah, you just click it and it downloads that as an image, which is really cool. And it's all dynamic. So here we've got label input, which is the green ones. And if I change that, just change its label to inputs, even though that doesn't make sense, you can see that it dynamically updates here. So it's a really cool little thing for generating pinout diagrams. So if you need to generate pinout diagrams, check this out. Could save you a bunch of time. I really like this. Good morning, Alistair. And welcome. So yeah, pinout leaf generator from SplitBrain. Nice. Very nice. As I said, I haven't used this for any of my own real boards yet. I just came across this and thought that it might be useful for people. So I'm going to try it. It's the sort of thing that I should try for my boards, because I've tried to do it before and I do it in a kind of a kind of dodgy way. Scott says seems a little bit simpler than my usual use of GIMP. Yeah, I used to do these sorts of pinout diagrams in photo editing software. I've done it in Photoshop, and I think I've tried it in GIMP years and years ago. But things like doing the text like this, it's just a pain in those sorts of packages. Things like presentation software. I use Keynote for a lot of things, a lot of pinout diagrams. And in fact, I'm just going to give a thumbs up to my sister's message. There we go. And where am I? I'm going to try opening. I'm going to open something to show you. Not that. I'm going to open a thing that I can show you that I did for a client, because it is not not such a proprietary thing. It's something that yeah. Oh, okay, so here's an example. This is a pinout diagram that I did for the water truck company a couple of years ago. You can see this version is from 2021. It's actually an old pinout, but this is looking onto the front of a DTM connector, so a Deutsch Mini connector, and it's got the different types of, like the colors for the different types of signal and labels.
Austin Creations said, "How did the truck factory visit go?"
Ah, Austin. Yes, I might get back to that. So yeah, this was done in Keynote, and I find that Keynote is great for this sort of thing, because what you can do is, or any presentation software, it's specifically designed for doing this sort of diagram. You can pull primitives like shapes like circles and things out, and you can style them. You can have a particular standard style for different things. And you can do snap to a line to get everything all perfectly spaced, and you can put borders on things, and yeah, so you can do really nice looking diagrams using presentation software. And for a job like this, I would still use Keynote, because you can see that this is not something that a pinout leaf generator could handle. This is a more freeform sort of thing. But for doing pinouts on board, like on pins and boards and stuff, this looks like a super cool tool. Just change that back to EN. Wonder what happens if you do an exclamation. Does it bar it? No, it doesn't. Oh well, that's cool. It would be nice if that did a bar over the top, but that's probably just a bridge too far. But even that, like this nomenclature with an exclamation in front of it, most of the, well, maybe not. I don't know. Certainly anybody that's really into electronics would understand that that's an inversion, but it's not necessarily beginner friendly. Patches welcome. Yeah. Oh, Anymule says, I've always used Visio for those kinds of diagrams. Yeah, well, Visio is specifically for diagramming, isn't it? So, yes. Gavin. Okay, so during the week was Electronex, which is the electronics trade show that takes place in...
Malik said, negation might be a different key like tilde.
Yeah, I don't think so. Yeah, I suspect that it just doesn't support it. It'll just be for doing labels. I'll put tilde on there, but yeah, it's just literally taking the taking the characters that are in here. It looks like what it's doing is it's taking this, it's splitting on the colon as the delimiter, and then so it's the definition of the pin name, delimiter, and then the pin type, with the type being defined down here. So anyway, Electronex during the week. Gavin was there. So Gavin put a question to me, because he has a question that he puts to his students which is what did you learn today, or what did you learn this week? I can't remember which, and to make students think about it. And he put it to me while we were at the show looking at all of the weird gear. It's oh, hang on, I said hello to Alistair. We've also got Russell Rainey and Alan Madsen. Welcome. He put it to me, what have you learned today? And said that what I should do is put that on the stream as a challenge to all of you. At the end of the stream, what have you learned today? I sound a bit like, oh, how have I gone blank on the Right to Repair guy's name? Lewis Rossman. Yeah, I sound a bit like Lewis Rossman at the end of the streams. And I hope you learned something. So anyway, point is, this thing is cool. And I'm going to, I'm going to try doing that for some of my devices. Now, next thing. This is a blog post that that John Spencer just posted in the Melbourne Hackerspaces Discord, and I haven't read it all. I've just sort of scanned down it, but it looks like it's got some really good information. So if you're into 3D printing, I'm going to chuck this in as well. Where's the chat? I've got to find it. Stephen W says, I learned you can glitch the Apple Ace 3 by shouting at it with RF. Oh, okay. I don't know what an Apple Ace 3 is. ACE3. I don't know. What is an Ace 3, Stephen? Tell me. Some Fun says, I learned my attention span isn't what it used to be. Yeah. DEF CON talk. Oh, okay. It was at DEF CON. Jordan said, I've been learning Hyperland and Waybar. Jordan, did I say hello to you earlier? I don't know. Design for 3D printing. And boom. That is now in the chat as well. What I should probably do is bring this up here and there, something like that, give or take. Not that you could really see very much. Hang on, let's see if I zoom in. Now you might be able to read it a bit better. Okay, so this particular post has, I'll bring this across. Has a whole lot of conceptual things and also practical things. So it goes through things like the objectives, like what you're designing for. Are you designing for a specific manufacturing method? Are you trying to make the cost low? Are you designing according to force, so making things strong, not just aesthetic? And terminology, and then it goes into a whole lot of things, like the obvious things like layer separation and strength. So making sure that force is applied across layers instead of between layers, etc. And then it gets into some really interesting things here, like the stress points on corners and the way force can be distributed, and reduce the stress point by doing a fillet in here and different strengths, and how strong things can be. So in this particular case, this I-beam is stronger than this solid infilled square, and it uses less filament, and it'll be lighter but stronger. So yeah, lots and lots of interesting tips in this post. So it's pretty long, it goes on and on and on. It's got all of these interesting things about different fitting. I intend to read this in detail because I'm sure that there is plenty of stuff in here in this post that I haven't thought of before. So it just keeps going. Goes on and on and on. Lots of interesting things. Tapping threads. This is like a Oh, and use of heat set nuts. Yeah. Appearance. Surface finishes. Surface texture. It'll take you a while to go through all of this. Checklist. Cool. But this is a very, very comprehensive guide to some really useful 3D printing techniques. So I highly recommend that you check that out, and then you can answer the question of what have you learned today? And you can tell me all about it next time. Where did the chat go? Oh, there. Scott says, I've relearned today that teaching geezers to use new phones still sucks. Yeah. Yes. Oh, Crispian says, Don S not here today. I haven't seen Don S in the chat at all. No. Yeah. There was that message earlier. So Don S arranged to send a disc to Crispian. Diesel Fiend. Did someone say dopamine? Yes. Now, next little thing, as pointed out by Amanda, I think it was. You can see there, over my shoulder. Okay, here is the question. I'm going to bring this back so that you can see. I've got to think about which side it is. That side. It's on my right side. You can see the SuperHouse thing there. I'm just going to turn the brightness down on it a little bit. It's out of focus because it's a fair way back behind. How do I change? Oh, brightness. Okay, sorry, effect intensity. I'll leave that up and I'll turn brightness down slightly. It's out of focus because of the camera depth of field, but when it's bright, it tends to sort of just blow out the camera sensor. So I've just turned it down to make it a bit more easy to see. So, okay, here is the question. And I feel so bad for having to ask this. Does anyone remember who built this? Because this was done years ago by a viewer and sent to me. And I have totally lost track of who it was that did that. Does anyone remember? Even better, the person who built that. Are you in the chat? Because, yeah, I'm really bad that way. I just forget names and I forget who did certain things. So what I've taken to doing, now that I know that I'm really bad in this respect, is labeling things. For example, I think about 2 years ago, I had some Unify networking gear loaned to me, and if I did not pay attention or make a note of it, I would forget who lent it to me. So I have put stickers on it.
Go back and watch the video where you first showed it.
Oh yeah, Amanda, that's what I should do. Go back into the mists of time and show the video of the display, because that was quite a. Crispian asked if it was Xeon. No, I don't think so. Back in the mists of time, it was quite a theme for a while, because I remember on the stream we were doing things like figuring out power issues. There were some big issues. I ended up putting capacitors, like electrolytic capacitors, scattered across it as bulk decoupling, because there are a lot of LEDs on that. It takes a fair bit of power, and we were having problems with the microcontroller resetting. No, it wasn't Austin. It was someone here in Melbourne, I'm pretty sure. It was a local person, because I think it may have been delivered in person. I just can't remember. Scott says. It's coming.
Scott Miller said, poor John, about to binge watch his own streams looking for it. Connor be some Grinch.
Yeah. I would not want to be doing that. Watching myself would be horrible. Live stream is 4 years old. Yeah, it was in the early days of the live stream, which was during COVID. Austin says...
Austin's_creations said, live stream is 4 years old.
Yep. BPM. There we go. I need a better color palette for it though. That color palette looks kind of bleh. Let's try. So that's just red, blue, green. Hang on. Color 1. What about random cycle? Did that actually change anything? I don't know. What about lava? Oh, I think it is. No? Yes. Party? Oh, it is changing. Okay, so when I when I change the selections on here, it doesn't reflect in the thing up above. Jordan said, is that WLED running it? Yes, it is. Temperature. Yellow out. Yellow blue.
Austin's_creations said, was sent by someone named James.
Ah, James. Was it James Kennewell? It might have been. That would make sense. Grant. Grant said, James Kennewell's amazing SuperHouse sign is too bright for my camera, but it flickers when run at low brightness. Let's see if we can figure it out. Aha! It was James Kennewell. Thank you. Jordan said, do you have segments for each word and the symbol? No, I don't. In the config here, oh, you can't see it. Let's do that. LED preferences. So I've just got an LED count of 388. I don't have different segments. Segments. Also, this WLED and Alistair says, Coen 2.5 VL can watch long videos and summarize them. Make the machine watch the videos and find the spot. Interesting. Yeah, so this is an old version of WLED. It may well be dramatically out of date. Linear wrap if moving. Back. Do we have... It looks like that's the user interface. I hate dark mode. Why LED preferences? Yeah, I'm pretty sure that I've seen a thing on here about segments, but maybe that is only in a more recent version of WLED. Oh, Amanda found it too. 28th of March 2021. Imagine a database of live stream chasing squirrels. 5 volts at 22 amps. And WLED install looks very out of date to me, says Mitch. Yep. Oh, so hello to Jax Tech, Mitch, and Diesel Fiend. Alright, now, where are we? Yeah, it would be very out of date. Do we want to... Security and updates. Do we want to do anything about this? Manual OTA update. So I'm on version 0.11.1 2020 release. Ooh, are we going to risk it? No file chosen. Download the latest 0.15. Download the latest release binary. Okay. Let's do that. Nightly. Unreleased. No, let's go for the release, just in case that was taken to a different place. Scott says, it's currently working, don't update, balk it. Yeah. Amanda said, did you mention it came from James? Yes, I did. It came from James Kennewell. So what I need to do, this is my plan. I am going to print a label. In fact, what I'll do is I go to Dymo, the Dymo app, and I go like this. Made by James Kennewell. I hope that is how it's printed. So I'm going to go, how it's spelt. Print. And there is a label, because I love my label printers. I have a label printer addiction. That was the Dymo. And over here I have the Brother label printer that does the chemical proof, thermal proof, etc. labels. Don't save that. And I'll put that label on the back of the thing so that next time I have this question, it'll say it right there. Add edit to the URL and see console. Ah, okay. Some Call It Fun has a clue. So what we should do is...
Some Call It Fun said, back up your WLED settings. Add edit to the URL and see console.
Okay. Index.html. Back up your WLED settings. Add edit to the URL and see the console. Okay, this is the console. So I guess I just save these somehow. Presets.json. Save. Nope, that didn't do it. Alright. Nope. Click on the left and copy paste to safety. Yep. Alright. Select that. And come down here. New terminal and projects. All right, this is going to be, what is this one? cfg.json. All right, what I'm doing is and then this one is this. How do I get back to the start? There. Select that and do presets.json. Okay. So now we have config and presets saved to my local computer. Dyslexic fingers. What did I do? Did I just misname something? Oh well, close enough. I would take an image or copy of its current state before update. I use this a lot in the UK to make flashy lights along 6 miles of roadway. Mitch, what? Is that like the biggest blinky installation ever? I mean, some people do lighting installations on the side of buildings, and you could say that's a big installation. Doing flashy lights along 6 miles of roadway, that is a very, very big installation. So where are we? Back to here. Releases, WLED, nightly release, pre-release. What about where's the sync issues, closed issues? Close, 15.1 beta. Where's the current stable release? There. Is this it? Is this it? Extended JSON assets. Okay, which one do we want? It's probably an SP01. To save me reading the docs, can someone tell me? I'll show all 22 assets. Okay, so ESP32, ESP8266 is probably this one, isn't it? Because this is running on a... Some Call It Fun says, wouldn't hurt to take a screenshot. Okay. Sorry, I'm a little bit ahead of the...
Some Call It Fun said, it wouldn't hurt to take a screenshot of the LED settings while you're at it.
Yeah. Just for you to... Mostly for the number of LEDs. Where is the pin definition? User interface, security update, sync interfaces. What's sync interfaces? Okay, that's when you got multiple devices and your device topic and WLED. Yep. Okay. So that's where you've got multiple device thingamajiggamies and you are connecting them so that they can synchronize. Where is the pin definition? Wi-Fi setup? Oh, maybe it's back another level above this. No? I was in settings. All right. Info, config, info. Config. Where do you define the module itself, like which pin it's going to be using for its LEDs? I can't see where that is. Don't know. I do not know. So, let's just do it. I think this is the one I want because at the moment it's running a Wemos D1 Mini. Oh, LED preferences, yeah. I went in there a couple of times and I could not see it. It's got LED count, type, brightness, apply preset, brightness factor, crossfade, duration, linear, skip first LED. There is no pin definition there that I can see, unless I am just totally blind. Apply preset 0 at boot. Yeah, I don't know. I don't know how it's telling WLED which pin to use. Let's just try this and see what happens. Okay, WLED 015 ESP8266.bin downloading ski. So, uses a default, says Jordan. Okay. Well, in that case, hopefully it will just defaulterize. Manual OTA update. And I want to choose... No, that's thumbnails. Okay. I'm going to go into my downloads folder, which means I'm going to do this. Downloads. Downloads. Where is downloads? There. And sort by date added. WLED. Okay. Now you can come back in here and update. Please do not close or refresh the page. Righty-ho then. So, we'll get rid of that. And actually, while this is happening, I'm going to keep talking to you, but I'm going to go and grab the thing that Lachlan left. Oh, it hurts to get up and walk. That Lachlan left on the gas meter. Oh, wow, that is tiny. This is tiny. This is not at all what I was expecting to see. I'm kind of slightly freaked out by this. But excited. It's this. It's a mysterious package that comes with a bag of parts. And in a moment I will open it and you will see the rabbit hole that I am in the process of falling down. Scott. Scott. Yeah, you know what's in my download folder. Okay, so this is an updated, I assume, where? Power timer config, segments.
Said, if you brick the WLED, you can always reload the old version via the USB connector.
Yep, that's right. I can flash it. We have the power. Right now you can see it is doing something and it's just solid. Okay, so let's try changing the color and we'll see if it changes. And it does. See, look, the color just changed. I'm just clicking on the palette and the color is changing, which means it's working with the new WLED. Let's get it to do something. What's blurs? I don't know what these... Breathe. Yeah, breathe is kind of a relaxing one. And yeah, here we can define segments. So what we could do as was suggested earlier by whoever it is that I can't remember already, what we could do is define segments to represent each of the letters, and then you could specifically address the segments and say this letter should be this color and this one should be this one or whatever. But I'm not going to do that right now. Breathing is awesome, says Scott. Yeah, I want to keep doing it for many, many years. A long time to come. Jordan, yes, thank you for your suggestion, Jordan. All right, for now I am going to... Scott says, oh, you're talking about the LEDs. Yeah, I knew that's what you meant. Alistair says, I use WLED plus Hyperion NG for Ambilight-esque backlight effects for my TV. Yeah. So for those of you who haven't seen Ambilight backlighting, it's, how do I describe this? It's a way of extending the colors that appear on the screen and backlighting around and behind the TV to match. So if, for example, you're looking at a view of a sunset on the TV and it was all red across the top of the screen, then the backlighting on the monitor or the display would also be reflecting red onto the wall.
Fun said, you now have the ability to back up the config.json data, FRMO the security and updates config section.
Ah, okay, cool. So I could back it up that way. The thing is that I don't really have anything set up on this. There is no, apart from the number of LEDs, and it's probably, well, second configuration. Yeah, it's carried over the configuration. So it knows, oh, it's got more options here. So we can do more configuration, data GPIO. Yeah, nice. Okay, a whole lot more configuration options there. But I haven't actually gone to any effort to set this up. It's just, it's got the number of LEDs set and that's it. So I don't think it's even got MQTT configured at the moment, which I should do because I want to now, yeah, that sign has been sitting in the front of the new lab for ages and not working, and I want to make it work because it's cool. Are we still trying to take over the world, or have we moved on to item 3? Oh, we long ago took over the world, David. What was I saying? I have no idea. Okay, so the new format of this show is the first hour and a half for squirrels, the final half hour for the actual topic. Now, I'm going to show you something. Although I haven't focused the camera, I am not that well organized. So I'm going to switch to this view. I turned on the overhead camera and I didn't focus it. Yeah, okay. Now, I want to zoom in slightly, focus, about there. Okay, this should do it. And in a moment, the focus assist will drop out.
Scott Miller said, overtime is for bodging.
It is indeed. Okay, now. Ooh. Yes. Yes. I have fallen down the rabbit hole. Now, this, I believe what is inside here is part of a keyboard kit that was made by Andrew, the pancake legend. So for those of you who have been along to a barbecue, you would have seen sauce. Many of you will have seen SauceBot and the sauce applicator that you stick your sausage under it. Oh, this is all very nicely done. I don't want to get into this too much because I'm going to do this properly on a future stream. This is just opening the package to see what's here and therefore what else I might need to get so that I'm ready for next time when I do it for real. Now, Andrew is kind of OCD and he So when he designs things, he goes to a crazy amount of trouble to make everything perfect. And he designed his own keyboard, and he was selling keyboard kits for a while. And this is one of his kits. So what I'm going to do is, now this particular keyboard is it's an ortholinear keyboard, which means that the keys are aligned in columns. They're not offset like a normal keyboard. So if I grab my Sculpt, for example, and bring it over here, this is a split keyboard, but you can see that the columns are offset, and well, the rows are aligned, but vertically they are not aligned. And there are a couple of other ways it can be done. You can also have it.
Creations said, all that work for your normal keyboard to end up in stock. Oh well, happy squirrel hunting.
Yeah. So so an ortholinear keyboard is like a grid. It's with everything aligned like this. So the columns are all straight, the rows are all straight, all of the keys are just aligned with each other, which is not how a normal keyboard is done. You can also have it so that the vertical, like the columns, are offset vertically relative to each other, which is fairly common with ergonomic keyboards. So with a regular keyboard, the rows are offset relative to each other, as in Exhibit A. In ortholinear keyboards, the rows and columns match, and in many ergo keyboards, the columns are offset relative to each other, often because they are split. So it's columns like this, and then the columns will be staggered slightly. So this is my plan. I wanted to see, oh, this is nice. Oh, it's PCB material. Oh, this is such a nice job. And look at this. This is the foam base, self-adhesive foam that goes onto it. And this has all been laser cut such that the laser has penetrated the foam and not gone through the backing. That is the sort of OCD, attention to detail, that Andrew does. And this is a weighted metal, so this is a steel plate, you can hear it banging against my ring, which goes in the middle of the structure and gives it mass. And I'm trying to figure out how this has been cut. It looks like it's water jet cut. Or was it lasered? I don't know. I don't know how to tell the difference. But this may have been laser cut out of steel. I haven't seen Pancake Legend in the chat. So anyway, maybe when I'm assembling this, actually assembling it, oh, and there's a piece of black paper, which has also been laser cut, I believe, as a spacer, and the PCB. Joink. This is an absolute work of art. It is so beautifully done. And my plan is that I am going to build this keyboard, and I'll do it on a stream. So now I know I need to get the keys. What we've got in here are the diodes that are used for the diode matrix. There's a build guide at that URL. And Andrew has a bunch of these kits left over. Oh, look at this. He's supplied these little balance bar assemblies. So for the space bar, because it's longer, it needs a balance mechanism. So the balance bar goes on the sides of the space bar, the switch is in the middle, and that way if you hit it off center or whatever, it doesn't just tilt the switch cap, but it actually depresses properly vertically. So that's a balance bar assembly that goes with it. Yeah, so if anybody's interested in building one of these keyboards, what else is in there? Looks like some other little parts of the balance bar assembly. I'm not sure. I don't want to get totally into this. I just wanted to open this and tease it because I am going to assemble this on a stream. Also, I have ordered a soft lay chalk keyboard and the keys and various other things. So I'm going to assemble this on a stream, on a future stream. And then I'm going to assemble the soft lay chalk keyboard on a stream. So let's close this up. Pretend this never happened. Oh, I'm not going to be able to fold this as neatly as Andrew did. Oh, I can try. Fold there, fold there. That goes over. Yeah. There we go. So that is the kit. The keyboard, if I turn it that way, you can just see the word keyboard coming through the paper. Yeah, so I think Andrew has been sitting on these kits for a few years now. He did this quite some years ago, and he's got a bunch of these kits left. And I'm sure he would be very happy to sell them. Last time, I don't know if the price has changed or anything like this, but when he was originally selling them, he was selling these kits for $125, which seems pretty decent given... Oh, and I'm going to need to add the microcontroller as well. So I'm going to need to get the board. I'll have to look up what it is. So we'll look at the assembly guide, but we will do that on a future stream. I'll look up exactly what other parts I need.
Said, don't forget to label it.
Yep. So yes, I do know who this one came from. And this is a bit of a giveaway as well. I will look up what else I need for it. I will order the key switches and the keycaps and the microcontroller. What else will I need? I don't know. I'll look up the guide. I'll have it all prepared, get all the parts here ready to go, and then we can assemble this on a stream. That should be a fun one. And if anybody else wants to build this same keyboard, I am sure that Andrew would be quite happy to sell off whatever remaining kits he has. I don't know how many he's got left. Probably like 20 or 30 or something. I don't know.
_creation said, you know now, but will you know in 4 years?
But will I know in 4 years? Okay. Oh no, I don't want to write on this because, yeah. No, I will definitely know because this assembly guide is to Pancake Legends GitHub repo. So yeah, it is inherent in that. Okay.
The biggest thing you need is time, I think.
Oh yeah, most assuredly. So what I'm going to be doing is building a soft lay chalk. Hang on, I'm going to bring up the ad for the keyboard that I ordered. So the soft lay chalk looks like it is almost what I want. This, and it may well end up being what I want. Go to cart. Nope, I do not want to go to cart. So the soft lay chalk kit 3. So this is a split keyboard, and on the soft lay chalk you can see that the columns are vertically aligned, but horizontally they are not aligned. So the columns are slightly offset relative to each other. It's got a spot for a couple of rotary encoders. It's got a microcontroller on each half. These are the sockets for the Kale switches, and it's got RGB LEDs, comes with the headers, all the stuff. It's got 2 displays. There's one little LCD on each half of the keyboard. And yeah, so that is on its way. I've also ordered the keys to go on this, and what? No, I do not want Java. I want coffee, not Java. So I have ordered keycaps and keys. So I ordered the KLH Sunset keys, which are tactile, sort of a moderate to low force, and quiet, fairly quiet. I don't want clicky keys. I want the feel, but I don't want that just annoying everybody while I'm typing. I can't stand the noise of keyboards. I like it when the keyboard feels nice and you've got the tactile response. You can feel when each key is activated, but I don't like the noise of just the machine gun sound. So yeah, so I've gone for tactile low noise switches, made by or manufactured by Kale, but designed by a keyboard enthusiast. So anyway, I'm going to build this. The thing that I'm not sure about with this, Java is a coffee brand.
Fun fact, Java is a cough brand.
Yeah, I know. That's why it was named. That's why the Java language was named that way. So the what am I doing? What am I doing? Oh, that's right. I was saying I'm not sure how I'm going to adapt to a keyboard that doesn't have arrow keys and that uses overlays. So it goes ka-chunk on each. Alistair said the correct thing to do is to mount a pinball solenoid under the desk so it goes ka-chunk on each key press. Yeah. Yeah, make a really serious amount of noise. Yeah, so the thing is, arrow keys and modifier keys and numeric keypad. I am used to the arrangement of having essentially a full keyboard and a numeric keypad. And of course I could keep the numeric keypad and use that in addition to the software shock. But I have a feeling that my brain may have trouble adapting to using layers for navigation and things. So we shall see. We shall see. I'm just going to have to try it. My gut feel is that the software chock will be really close to the keyboard that I ultimately want, but that I may want to modify the design slightly to add navigation keys, like down here in the bottom right area. Yeah, cartoon pic at your old lab showed you at the keyboard and it said shika shika. Yeah, I wonder what happened to that cartoon. I don't know. All right, how about we look at some Rack32 stuff? So yeah, this is what's coming. In a future stream, I'm going to assemble, I will assemble Andrew's keyboard and then I will assemble the software chock. Although it's possible it may be slightly out of order. Gestures. Alistair says mount a leap motion in the desk and use gestures in lieu of arrows. Maybe. Yeah, but then yeah, gesture driven stuff leads to Henrik says, why you need arrow keys? Can't you just use voice and say move left 6 pixels? Usually because that's slower. Voice control can be quite slow. What? Okay. Where is this? Here we go. Here we go. Okay, now, this is where I'm going to have some questions for Austin, because this is, am I on ignore violators? Yes, I am. Okay, I'm going to grab that. I'm just going to stick it over here for now so that I can do that to fit. And move these a little. Yeah, okay. Now, since we were last looking at this, I have been thinking through the whole power supply part of this design. Now, I could just do placements and routing as this schematic exists right now. Hang on, I've lost Oh, I know where it is. Chat ended up over here. I lost chat. All right, now I'm going to come back to here, bring this here, and I'll bring the chat over where I can see it. You won't be able to see it, unfortunately. There. Okay. Now, so schematic time. Austin did some cool stuff with the power supply, part of his version of the board. Power supply. So what I've got here, all right, I'll do a quick review just to show where this is currently at. And this is a very basic, you could consider it to be a naive, hang on, where is the, what? Hang on, did I delete it? No, I didn't delete it. It must be elsewhere in the schematic. That's strange. Where in the schematic? Why isn't it on this page? Ah, because it'll be on here. Let's move this because I want to put this into the same context as the other parts of the power supply so that we can see all of the power supply stuff in the same place. I'll vertical align that, and it just extended the label because it moved it, of course. It's on a new sheet, so let's regularize the spacing on that. Okay, and that would break my brain, having it like that. I need to move this up. In fact, what I need to do is move that up, and I need to move that down. That feels better. My anxiety level just decreased. Okay, so what we have is a DC in connector here, which is feeding through a diode going to the 12 volt rail. So we've got a 12 volt rail which goes into a 5 volt regulator, and then from the 5 volt regulator to a 3.3 volt regulator, which gives us the 3.3 volt rail. And that rail is powering a bunch of stuff. So, LCD header. So I have a question, which is, do we need 5 volts? I have a feeling that we probably don't. And that would make me very happy, because what I could do then is ditch the linear 3.3 volt regulator and change the switch mode regulator to output 3.3, and then potentially what I could do is replace the PoE module, the DP1435, with another LM38020, and have one doing the 12 volt regulation and one doing the 5 volt regulation, because we need 12 volts. But, okay, my brain is jumping around all sorts of ways. Let me lay this out, and you can tell me if I'm being stupid, and whether this conceptually works. All right, back to the power supply section. I'm just going to go back to where I was before and hopefully get myself back on track. So we have a 12 volt rail. We need a 12 volt rail. Let's start by stating the objectives. We need a 12 volt rail because we have to supply 12 volts to other boards like RJ45 breakouts for light switches and for smoke detector boards and PIR boards and all of the other things that might be connected to this. So we need a 12 volt rail. We also need...
Tabray's Malik said, I don't know much about the project, but it looks licked. There's USB in the top right corner for 5 volts.
Yeah, but you may not have USB connected. Ah, but yeah, you're right. So we would, if you're going to be powering it off USB, like just when during development or whatever, we need to allow for that. So to Braze, that is a good point. Austin says USB is purely for programming. That's right. But you may want to be programming it with the Rack32 sitting on your bench, just plugged into your computer and no other power source. In which case it is quite valid that you would want to power it off the 5 volts from the USB. So that is a good point. We've got to keep that in mind. So we need a 3.3 volt rail, we need a 12 volt rail. Those are the only two things that actually matter. The 5 volt rail only matters in the sense that it can be used to power other things like the 3.3 volt rail. So taking the 5 volts, feeding it into a regulator and dropping it down to 3.3 would be the thing to do. Oh, other people in the chat. David C has arrived and DIY in the ghetto. Okay, so yeah, Austin says, yeah, it doesn't make a difference for removing the 5 volt regulator. The 3v3 is what powers the MCU. Yes. Now, Austin, this is the question, which is PoE regulator and bypass. On one of Austin's boards, he did some clever experiments with setting it up so that the power source could be auto-selected. And he's using a different regulator. Instead of the LM38020, which I'm using here for creating the 5 volt rail, Austin is using a different switch mode regulator, which I think may have a higher power rating. I think it might be a 5 amp regulator from memory, but it's also one that is very expensive. I could be wrong about that, but my recollection is that it is high current, like 5 amp rated, as opposed to 2 amps on this one. And it was stupidly expensive, like 12 bucks or something just for the regulator chip, whereas this is like $1.50. So, where are we? Yeah, so, and the other thing, of course, is there were all of those mysterious regulator failures on the current version of the Rack32. For some reason, the 3.3 volt regulators have been failing. Some people have had them fail, and it is still a bit of a mystery as to why. If you overload the 3.3 volt rail and pull more than this regulator can handle, it should just go into thermal shutdown. It shouldn't die. But these regulators have actually died a couple of times. And it also should not be caused by back powering. Oh, LM2596 S is my normal regulator, which is 3 amps. Yep, so that's the one that Austin uses. Very good. So this should... I don't understand what's killing this. Back power shouldn't kill it. Over voltage shouldn't kill it. Like if this 5 volt rail, I think the highest that you can handle into the AP2112K or whatever it is that's on here is like 6 and a bit volts. But even if you go over that, these shouldn't die. They should just stop working until you... Yeah, okay, so Austin says combination of issues caused the failures. Heat and current usage plus hot plugging that couldn't handle the current draw. Okay, so hot plugging causing problems on this. Yeah, so the 3.3 volt rail going to like an RJ45 breakout with a bunch of bulk decoupling on it, so some big electrolytics, which would be pulling power off the 3.3 volt rail. So this would be doing a sudden load, like a sudden current surge, a big dump into bulk electrodes. Right. Okay. So that would be a problem. And Austin says, granted, hot plugging was killing I2C the most. Yes, it did that, didn't it? Oh, pardon me. Okay, did anybody else catch that yawn? Catch it through the internet? The question is, should I get rid of this DP1435, this is the PoE regulator, and replace it with an LM38020? So the 38020 can handle up to 60 volts, I think, on its input. So sending it 48 volt PoE power is not a problem. What I could do is I could have two of these, and I could make, Imi caught the yawn, right? So I could have two of these, one set to 12 volts output and one set to 3.3 volts output to replace this, and drop this module so I wouldn't have the DP1435 anymore, and then potentially have some kind of like auto switching. So if that went through a diode, so we got 12 volts out through a diode onto the input side of the 3V3 regulator. Now the thing is that the way this circuit is set up right now, this would work, but we would potentially continue to have the 3.3 volt power supply problems. And I don't want to have that happen again. So I am fairly strongly leaning towards replacing this 3.3 volt regulator with the switch mode regulator with an LM38020. Stephen said, but you wouldn't have the negotiation for PoE 802.3 AF-AT. Yeah, so that is the unknown. And this is what I'm curious to know, is what Austin managed to discover about that. So what Stephen W is getting at there is that this module, just represented by a little box on the schematic, the DP1435, is a PoE regulator module. What you do is you feed in power to it from the Ethernet coming in on the wire, and it gives you, in this particular case, 12 volts output. And, ooh, I think we're going to get some music. Pete? Yes, it'll come, it'll come. Nice one, Pete. Member for 24 months. Thank you. Hang on, I got a mute and cough. Okay, maybe I'll feel a little bit better now. Maybe I won't sound quite so bad. Okay, so Austin says, the regulator is highly reliant on resistance values. I'd keep it. It was why it was so hard to design the auto module without it failing. Non-DIY PoE. Right, yes. Okay, so Austin's recommendation is to keep that 12 volt regulator. So, okay, I think what we can do though is we can simplify this. We can keep this regulator as it currently stands, which will give us support for either pass-through PoE with those jumpers in place, or proper 802.3 PoE. Whoop for Imi. If you want a higher current regulator. Stephen said you always replace 3.3 volt reg. No, I'm not going to sing anymore. Okay, Just-O-Matic 22. I just want to check the values in this, because on the current version of the Test-O-Matic, I've got 3 power supplies, all with the 38020. Here we go. And we've got, where are we? Oh no, those are the INAs. Here we go. 5 volt regulator, 38020. Oh no, they're not all with that. What? DUT, why is that an AP2112K? Okay, well that's something that I could improve in future. So this has, so it's 24K9 and 100K on the feedback. So that is for a 5 volt output. That's the AP2112K on there. I thought that I was doing, maybe I wasn't. Yeah, I obviously am not. I thought that I had an LMR 38020 here outputting 3.3 volts. But no. Jordan said, on the hot plug issue, is there a way to limit current until the caps are almost full? Yeah. I can't see a neat way to do that. Austin says, but also stop hot plugging your stuff. Yeah. So, all right. Do we need the 5 volt rail? I don't think we do. I think what we could do is feed USB 5 volts onto the 12 volt rail through a diode, which means that the power would therefore, so you'd never back feed into the USB, and then it could also feed into the 3.3 volt regulator and change this regulator to output 3.3 volts and drop this. So, do we need 5 volts anywhere? Anywhere at all? Like for the, do we use it on the LED? Is there like an RGB LED or something? I don't know. Okay, I'm going to pop this out as a separate window, and I'm going to unfortunately drag it down out of your view temporarily, only because this this isn't big enough. So where is the 5 volt rail used? There is the regulator. It comes in from USB, goes to there, and it's on the programming header. It's not used anywhere. So I think it's safe. Okay, here we go. I am going to do some...
Austin's underscore creations said, click highlight net.
Yep, I did. You just couldn't see it because it was down on the other monitor. Okay, so here we go. I am going to do the irreversible. So we've got a couple of 22 microfarads there. We've got a 220 bulk. What else do we need or care about? I should probably put some 1206 4U7s on the input side. Oh, hang on, I got a cough again. And the final sip of my Bunnings coffee. All right, I'm going to do... I think I have enough of a plan formulated in my head that I am just going to start ripping and replacing. So here we go. Let's do the thing. So we've got a power LED there on the 3.3 volt rail. We've got a 10 microfarad there. We've got that regulator. Let's go.
Austin's underscore creations said, I would put a bulk on the 3v3 side, however, to handling and burst from TFT lighting up and radios booting.
Yes, you are absolutely right. And Austin, you are about to see that we are going to get the benefit of that from this change, because what I'm going to do now is go delete. See that? It is gone. Delete. I'm going to go delete, 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 and delete, because we are not going to have a 5-volt power supply anymore. Let's join. Hang on, why didn't those join? Oh, they did. Okay, just in a very awkward way. Join that on there. Yeah, it's got a split in it. Let's do a an optimize. Hang on, rework, optimize on boom and boom, and then here is the magic part. Obviously, I'm going to move some things around. Yes, I want to merge that into that net, and then I want to go droink. Yes, I want to merge it into ground. Let's do this, and I'm going to have to do the calculation to figure out yeah, to figure out, sorry, what am I thinking? I don't know what I'm thinking. Oh yeah, the voltage divider for the reference voltage here on the feedback on this regulator, because this regulator is currently set for 5 volts output, and I'm going to change it to 3.3 volts output. So it is currently coming off the 12 volt rail here. Now I want to change something else. So we've got 3v3 there, LCD header. Oh, what is my stomach doing? Okay, so now we've got a 3.3 volt power supply, or we will shortly, that once we change these resistor values, I should do that before I forget, because it would be bad if LM38020 datasheet. It'd be bad if I forgot and then we started shoving 5 volts down the line. Simple switcher. Here we go. Where is... do I have a note on the calculation somewhere? I probably do. At some point when I've done this, I've made a note. 4.2 volt to 80 volt input range. Yeah, 80 volt. That's right, not 60 volts, 80 volts. So our FBT and our FBB are the ones that we need to calculate. And where do we do that? Where? FBT. To calculate the top side resistor, use equation 1. Select the bottom side resistor for the desired divider current and use equation 1 to calculate the top side resistor. Recommends RFBT in the range 10 to 100k for most applications. Yes, okie dokie. And have we got some examples here somewhere? Surely there are some examples. Come on. Okay, RFBT is Vout Vref over Vref, RFBB, so adjustable output voltage. Okay. Let's do, so we want 1 volt out of 5, 24K9 voltage divider calculator, because I am lazy. I'm going to put in the values that we can have at the moment. So if we've got a source voltage, we want a reference of 5 volts. Oh, go away. Ads, close. The high resistance we've got is 100 kilo ohms, and the low side is 24.9 kilo ohms. Let's see what it calculates as. Oh, get out of my view, you stupid ad. Calculate 0.997. Yep, so this is how the current system gets the reference voltage, the 1 volt reference voltage, is actually 0.997, so it'll be slightly overdriving the 5 volt rail. Now, if we want 3.3 volts as our reference, and we want to get 0.65, it's currently 0.658, so if we leave that as 24K9, what happens if we get rid of that and we want 1 volt reference, calculate, alright, so we need a 57K resistor on the upper side and a 24.9 on the lower, but what happens if we calculate for a 100K on, 100K on the top with a 1 volt output gives us 43.47. Okay, so do I have any 40? What is the nearest resistor value? Resistor values. Standard resistor values.
Imogen Ann said, "You say lazy, I say outsourcing, haha."
Yeah. Okay, 1% standard values, E1, E96. What were we going for? 43.478 is our target. 43.478. There's a 43.2. So if we, okay, let's see how that turns out. If we make that 43.2 K ohms, we get an output of 0.996. That's nice. Okay, so 43.2 K ohms. Beautiful. So this resistor, R29, now needs to be 43K2. Is that right? 43K2? Yes, 43K2. All right, so that should now give us a 3.3 volt. So when we've got 3.3 volts coming out on here, this voltage divider will give us 0.996 volts at this center point, which goes back into the feedback pin on the regulator, and that will hold the regulator's output at that 3.3 volt target. Perfect. Okay, so now we have an LMR 38020 configured to generate to output 3.3 volts, which gives us, so we've got our power LED, we've got the external power LED, that's the one that's on the front panel, we've got the LED that's on the PCB. We have a couple of 22 microfarad electrodes for high speed response. We've got a 220 microfarad, oh sorry, no, these are ceramics. We've got a 220 microfarad electrode for a bit of bulk on the 3.3 volt rail. We have a nominal 12 volt rail coming to the input side of the regulator, coming from either the DC jack via a diode or from PoE bypass via a diode, or from the PoE regulator via a diode. Noticing a theme here. Now, the one thing that we don't have sorted yet is if we have a look at the programming header and the USB header, these are going into the 5 volt rail, and the programming header also goes to the 5 volt rail, and we don't want that anymore. So what I'm going to do is come back here and copy, because it is the quickest way to get the thing with all the attributes. I'm going to copy a single item as if it's a group. Copy group and swipe it over here and take that. Or maybe what I could do, maybe I don't need to change that. I can do it on the other. I'll treat those two as if it is. Yes. Okay, forget that idea. Forget that. I'm going to do the same thing functionally, but represented in a different way. What I'm going to do is over here, we are going to do this. Why did those nets come with it? Get rid of the nets. Get rid of that net. And I'm going to, and this is kind of ugly, but I can do some cleanups later. I'm going to add a supply symbol for 5 volts. Yes, and there. Link that, and now we have, I wonder if I can, I think I will, for the sake of cleanness, I'm going to bring this in, bring this down, and this, and this. Where? Okay. Getting there. Still kind of ugly. Ooh, I don't know how I want to represent this. I think I want to represent it so that's an input. That's an input. We are ORing them, essentially. Let's align the diodes. That would be better represented up here. And get rid of that. Then that would be better represented over there. Yeah. I know, this looks wrong here, having the 5 volts and the 12 volt rails joined by a diode. It kind of makes sense, but it does look wrong to me. Now let's just take this and relocate some things. I'm trying to, I mean, technically it was correct before, but it didn't look correct. And I don't like it when things don't look correct. I want it to... Still not good. Okay, bring that in there. Let's join these and get rid of this. And take that up to there. That is such a messy little bit of schematic there. I hate it. I hate it. Precious. Let's give myself a little bit more room to work with, and maybe I can come up with a more aesthetically pleasing and logically representational version of that. So we've got the input rail, which is at 12 volts. I think...
Tabraze Malik said, I agree with Stephen W.
I missed Stephen W's comment, so I'm going to have to check that out. What did Stephen W say? Bring that to there, bring that down. Okay, yeah, I haven't actually been looking at chat. So Tabraze, thank you for pinging me through TTS. Where was Stephen's comment? Rather than calling it 12 volt, maybe V input. Ooh, I understand why you're saying that. However, it does need to be 12 volts because we kind of rely... All right, that 12 volt rail is connected to the output of the PoE regulator. Here, this module, the DP1435, outputs 12 volts. And we are actually relying downstream on this being 12 volts. So if you power it with bypass PoE, you need to send 12 volts down the wire. If you power it with 802.3 PoE, then it doesn't matter, like it'll do 48 volts or whatever, but you get 12 volts coming out. So this should be a 12 volt rail, which is the same as this rail right here. So I think it needs to stay as 12 volts, not just VN, because VN is kind of yeah, DC in fact what I should do is change that value and make that 12 VDC in, because I need to be explicit that it should be 12 volts, and we don't have a 12 volt regulator other than the PoE regulator, which is not ideal. Yeah. Yes. So we're in the situation now where this is technically correct, but it looks ugly and it is not self-explanatory. I would prefer it if these caps were there, that was not connected there. Let's try this. Move that to there, move that to there. So those are aligned. Bring that back to there.
Tabrez Malik said, it should be 12 volts or 5 volts, otherwise the diode is never forward biased.
It will be forward biased if there's no power available on the 12 volt rail, in which case this 12 volt rail will be 5 volts minus the diode's voltage drop. So maybe what I need to do, okay, what I am going to do is put a little explanation in here. And writing this will help clarify things both for me and for everyone else. So maybe it'll be a useful exercise. Oh, I hate that you can't resize this. What? Oh, hang on. Can I? No, you can't resize that window. Okay, here we go. Power scheme. 12 volts is required. Okay, then, oh, okay, it auto resizes. DC in must be 12 volts. DIY PoE must be
Austin
12 volts.
Creations said, I think the 5V should be isolated from 12V, especially when going to the IDC connection.
Yeah, it is via the diode. Unless I'm misunderstanding what he's suggesting. So DIY, I'm gonna do brain dump these notes and then figure it out. 802.3 PoE provides 12 volts via the DP1435 module, and when no 12 volt rail available, 5 volt from USB or prog header supplies the 12 volt rail to 3V3 regulator. Okay. So, do I need to make that shorter?
Austin's _ creations said, no, it's not the diode directly gives 5V to that IDC connection the way you currently have it.
Oh, yes, yeah, that's fine. That IDC connection is just a breakout for USB headers, for bringing in USB from a computer. So, all right, so this 5 volts here. So we've got a 5 volt rail. I'm gonna trace out the 5 volt rail just to make sure that I am correct about this, because I might have screwed this up. We have a 5 volt rail connected via a diode to the 12 volt rail, so that if there is no 12 volts available, so that means you've got no DC in, you've got no PoE of either DIY or normal PoE, so no 12 volt supply, it's just sitting on your bench plugged in on USB. That will provide 5 volts minus a bit to the input of the regulator.
Austin's _ creations said, I'm talking the main 2x3 IDC.
Ah, the main. Does that have 5 volts on it? Okay, let's check that out. I might have screwed that up. So so that then supplies just under 5 volts to the regulator to supply the 3.3 volt rail. So if you have no 12 volt supply available, you just plug in on USB, you should still get a 3.3 volt rail. Okay, now, where else are we looking? So let's check out the LCD header. Only has a 3.3 volt rail, so that's good, no 5 volts there. The I2C breakout has the 3.3 volt rail and the 12 volt rail. So what will happen is that there will only be 5 volts supplied down here in that situation. But that's just like a programming it on the bench situation. So in that case, you can't power properly whatever 12 volt devices you've got down here. So I think that's okay. Now let's look elsewhere. Just have a quick look on this one. That's just Ethernet, so that's all fine. Now this is where problems might possibly be. We have the spare I/O header, which has a 3.3 volt header only, no 5 volts. We've got the programming header, which has the 5 volts, which is fine. This is just, this header, this programming header that you see here, this is just a breakout for USB coming from a computer. So this is exactly the same as plugging into the USB port on the front. This S3D plus and S3D minus are just the USB pins.
Creations said, we do not want 5V going down that rail. It'll create way too many issues.
Okay. So before the, unless you pull the 12 volt pin to before the diode. Yeah, okay, so what you're saying is if you've got it sitting on the bench and you've got something like an RJ45 breakout plugged into it and you plug in USB, you do not want 5 volts going down the 12 volt rail to the other devices. It would cause no problems for the Rack32, but it could potentially cause problems for other devices. Right, okay. Thanks, Austin. I think I understand now. Let's see. So, we have that going to there. We have this one here. So this is the issue. The 12 volt rail on this being supplied with 5 volts when you only have USB plugged in and nothing else. Okay, what can we do about that, and does it really matter? I don't know. My feeling is that it doesn't matter, but I'm keeping an open mind because I don't, because you may well be seeing problems that I don't see. So I'm just trying to understand why this is a problem. So if you've got a device at the other end, and I'm thinking of use cases. So some call it fun says attach it to 12 volt DC in before the diode and it is either 12 volts or nothing. Before this diode, but the thing is that it could be, there are multiple diodes. There are 3 diodes feeding, in fact now 4 diodes feeding the 12 volt rail. So we can't, if we connect it before this diode, then we'd only get the output from this regulator. If it's before this diode, it'd only be that. If it's this diode, it'd only be the V in. So that's not really an option, unfortunately. Jordan, oh, wagon loads, yes, you're early. You got here early, good. So Austin says the problem will be the end user, and there could be many things powered via the 12 volts, let alone a security board which does use 12 volts directly, let alone what can be plugged into an RJ45 jack. Yeah. However, this is... Yes. And Tabraze is about to say something on TTS as well.
Tabraze Malik said, do you have 12 volts devices that have SMPSs hanging off the 12 volts? How will they react to constant 5V?
Yes. That is true. Okay. So, it seems that there is a consensus for everyone except me that it will be a problem, that this will be a problem. And I think what's going on is I am thinking of the use case that you would never power the Rack32 exclusively from USB with other things plugged in, because that would be a situation where you've got it on your bench and you're plugging it in to flash it, for example. But if you have it actually in use, you need a 12 volt power supply. You can't run it off just the 5 volt supply, because if you've got it on the bench and you have something else plugged in and you're not supplying it 12 volts, the other thing is never going to work. And you wouldn't expect it to work. It's like that's a broken setup, because you can't run 12 volt peripherals off it when you don't have a 12 volt power supply. Scott says, good power at using USB PD and call for 12 volts. That is true.
Austin's_creations said, that's like saying, why would someone hot swap modules? Well, the Rack32 powered and programmed and running debug output.
Yeah. Yeah, running debug output. But in that case, you'd have a 12 volt supply. Okay. All right. I concede. I don't see this being a problem.
Tabraze Malik said, I would consider the situation where it's in a rack and people are flashing an update. You don't normally unplug everything before an update.
Yeah, that's true. But he would also have a 12 volt power supply. So, okay. One option is to just not allow it to be powered off 5 volts. But then if you've got it sitting on your bench and you're flashing it, it means you have to plug in a 12 volt power supply to power it. So how do we get around this? Okay, so the goal here is that we do not want to feed the downstream 12 volts here when only 5 volts is powered on. So there could be like an auto switch circuit. Yeah, Crispian said, in the use case scenario where the 12 volt power supply fails and the system is left trying to operate. Why not just take the 5 volt straight to the programming connection? Isn't that what we do? So the TTS will catch up in a moment. Okay. How do I feed that into there without it back powering into there? I could do that with another diode there. I think this problem can be solved with one more diode. Okay, as a thought experiment, let's do this. Hang on, I'm going to rearrange things here just slightly and allow this to work. Then that would be there. Yeah, okay. I think this will work. Yeah, Jordan says, add a single diode between the 12 volts output of the other outputs and pull the power for the other boards before it. Yeah, that's right. This is what I'm doing. So what I'm going to do is isolate this and put another diode in here. Now, but I just want to give myself a bit of working space first. So I'll move this back over here, and then I want to Okay, let's isolate that, move that out of the way just for now. I'm going to isolate that. I've got that going into there. I'm sorry, the reason I'm pausing is I'm puzzling over which side of the diode to put these caps in, but I'm pretty sure they need to be on the input side of the power supply. So I'm going to move this out of the way. I'm going to take this conceptual dotted line over here. So the 3.3 volt regulator has the caps on its input side directly associated with it. Okay, regardless of where the power comes from, these caps are going to be associated with that regulator. I need to give myself a little bit more room. Move this along here. So that goes to there. I need another diode. And so we've got that, we've got all of those inputs, we've got the 12 volt rail there, and bring that to there. And this should conceptually fix the problem. It's just not a very neat representation, so then I can clean that up. Alright, so let's see if this logically makes sense. We've got, and this may not be the best place to do it. It might be better if it was somewhere else on the schematic so that it's more self-explanatory. So what we've got now is 5 volts, if it's supplied here, will go onto this rail, which is what? Let's call this, no, it's just, it doesn't need a proper name. I was going to call it like VN or something, but doesn't matter, it's just a net. So we've got 5 volts from USB can supply the regulator through a diode, and the USB can't be back powered because of the diode. And it also can't supply through to the 12 volt rail, and that handles that situation. So 12 volts goes to there, so we've got input from DC goes through a diode to the 12 volt rail through another diode to supply that. I know you're all way ahead of me, but I'm just thinking this through to make sure I've got it. And then we've got the source from the bypassed PoE and the regular PoE going through diodes to the 12 volt rail as well. So either of those sources, any of these 3 sources will supply the 12 volt rail. The 12 volt rail can supply the regulator, and 5 volts can supply the regulator. Can anyone see any flaws in this scheme? Can a full wave rectifier work here? I don't think we need a full wave rectifier. So Stephen W said, yep, we've done that. Add a single diode, says Jordan, yep. Jack says, all you need is, oh Jack, I don't think I've seen you in the chat yet. Where's the chat list? Okay, so we've got Wagon Loads, Adrian Higgins is here, Pete, Gorilla AU, Dodgy, Jack. Yeah, a few people have joined the chat since I was saying hello. Is voltage drop going to be an issue? Some call it fun. Tabrez says,
Fun said, is voltage drop going to be an issue? Tabrez Malik said, no, you're good to go.
Yep, okay. Oh, and Jordan says, does the ground side of the PoE regulator need a bypass? Jack said, all you need is an isolated DC-DC buck converter so that 12 volts can power the ESP32, and you can still power it from the 5 volt from USB for local reflashing. Now... yeah, so this is an isolated buck converter. this DP1435 module, which is coming in off PoE, but it is only in use when we are running 802.3 AF PoE. The rest of the time it doesn't. Now, where was that? Yeah, Jacksec said, voltage drop, you now have 2 diode drops. Yes. Therese asked, do you need D1? Where is D1? Right there. I think we do.
Tabrez Malik said, do you need D1?
So D1 is this one right here. Now, I would prefer to have it in there as a bit of safety. You are right that maybe we don't need it. This is the DC in jack. Now what that is doing is providing isolation so that if you feed power down PoE through here onto the 12 volt rail, it does not back power out of this power source. Because someone might have, say they've got a 12 volt power supply plugged in here, and then they plug this into an Ethernet switch with PoE, and all of a sudden you are back powering this power supply. So the goal here is to avoid back powering, and we've got a variety of power sources. So we have 4 possible power sources, and we don't want any problems regardless of where the power is coming from. So now, is this voltage drop a problem? In each case, we have 1 diode between the power source and the 12 volt rail. So it doesn't matter which of those three things it's coming from, there is always just 1 diode of voltage drop, and this is a Schottky. So it's an SS56 Schottky diode, which has a fairly low, I can't remember what the forward voltage drop is on it, but it's like 0.2 of a volt, 0.3 of a volt. It's pretty low. So we've got a low voltage drop to the 12 volt rail. Then we have the 5 volt rail through a single diode to supply the regulator. So that should be enough overhead for the 3.3 volt regulator. This can operate from 4.2 volts on the input side and still run. So we should be safe with that. Then we have two diodes of voltage drop from each of these sources. So these are nominally 12 volts going to this 12 volt rail. It'll actually be slightly below 12 volts. And then through another diode going to the input of this. So there'll be another voltage drop here. So there'll be a double voltage drop going to the regulator. But that's fine, because this is 12 volts-ish with a double diode drop, but this only needs 4.2. So we've got heaps of headroom, miles and miles. There's no problem there whatsoever. Okay, so Stephen W said, is the 7 volt reverse from 12 to 5 going to be too high for the diode? No. So what Stephen W there is talking about is 12 volts here on the cathode side. So in this situation, what we would have is 12 volts on the cathode of this diode protecting the 5 volt rail. So there's a 7 volt delta there. No, SS56s are rated to, I think, I should look this up because I don't actually know. I think they're rated to about 60 volts or something. SS56 diode, what are the specs? Yeah, 60 volts, 5 amps, 60 volts. Here we go. So this is the diode that I'm using in this situation. It is rated to 60 volts, 120 amp surge, 5 amp continuous. So, so that'll be fine. Hang on, what's that? Ads. Okay. Some Call It Fun says, today I learned that diodes are still super useful. Yeah, I know. It's easy to overlook diodes because they're such a basic fundamental thing. But they are, I haven't saved for ages, but they are actually a really useful building block. So sometimes the simple things are the solution that you're looking for. Austin has a question. Austin, ask your question. Here it comes. And Austin says...
Austin's_creations said, how are we not running ad blocker?
Yeah, that is a good question. I should do some ad blocking. I should set up Pi-hole or something. I've had it running in the past and I just don't have Pi-hole running right now. Now, I have done zero routing today. I'm going to, because of Mother's Day events, I can't really run overtime today on the stream, so I'm going to have to bail soon. But I think we now have a resolution on how to handle the power on this updated Rack32. Wagon Load says 2 diodes can make a simple logic gate. Yeah, well, that's what we're doing. We are making OR gates. Yeah, you can go crazy with diodes, do all sorts of things. Now, if only diodes were ideal, you could do anything. It's when you start having multiple diodes with cascading voltage drops that you begin to have problems. But yeah, with an infinite supply of ideal diodes, you could build whatever you want. I wish that was how reality worked, but sadly it doesn't. So we've now got a 5-volt rail coming from the programming header or the USB socket. We've got 3.3 volts coming off this switch mode regulator. We've got a 12-volt rail which can be supplied by the DC jack or either of the PoE methods. And our 12-volt rail is isolated from the 5 volts so that it can't be back powered from 5 volts. So I think we're good. I think we are... Let's redock this tab. I think we are ready. What have I got here? A couple more diodes. Okay, these are the new diodes that we added. And ready to start setting things up and routing. But that's not going to happen today because I got to go. All right, so now that we've talked through all of this, oh, and this is supplies. Supplies the 3.3 volt regulator. USB prog header, yeah. So we'll say when no 12 volt rail available, no power supplied on 12 volt pin to downstream devices. Okay, I think that makes sense. And hopefully everybody is happy. So even if you're powering it on the bench off USB only and you got downstream devices plugged in, they will get a 3.3 volt rail, but they will not get a 12 volt rail running half-assed at 5 volts. Okie dokie. Is your PCB connectors in a locked location or can they be moved anywhere? They are, I should lock them. So let's see, edit, where's the modify? 0, there's lock, lock. All right, I'm going to lock that one and lock that one, that one, that one, and that one. Okay, those are the only things that we care about locking. The RJ45 connector on the front panel and the USB, because they have to go through holes in the front panel of the rack mount enclosure. This header, because it's the expansion header, that things need to, in fact what I should do is also lock these holes. Did that work? I don't know. Then this header, because the IDC cable goes along to the adjacent device and being in this position makes it all the cable routing neat. This header for similar reasons, because it goes to it passes typically underneath the adjacent device down to the other end of the case to the LCD, and that because add-on boards on top expect that expansion header to be in that location. So everything else, apart from the mounting holes, is up for moving. We can move other things around as we see fit. But those connectors are now locked in place. Okay, and once again, save. So now I can begin with the actual routing, putting everything in place, set the power supply up in here, move these diodes and things in here. Looks like there'll be room. I think I can make that fit. But not today, folks. Not today. Do the add-on boards expect 5 volts? No, they do not. Oh, John is here. John. Okay, we'll go back to the start. Jack said you could also do with a few NPN transistors to disconnect the 12 volt rail when 3v3 exists, preventing backflow. Yeah, but I think we've solved the problem with some diodes, so that's fine. Yep. Okie dokie. No, sorry. So Jordan, the add-on boards, there isn't actually even 5 volts on the header. So we've got the LCD header, which only has 3v3. We've got the I2C header, which has 3v3 and 12 volts. And 5 volts is not exposed anywhere else on the board. The only place it's used is as a power source for this. We've got no 5 volt peripherals at all, and no external, like no headers that have the 5 volts. So I think we are good to go. Yeah. Okay. It is, as Crispian is about to tell us,
Outside the box said, it is Uru time.
It is indeed Uru time. Would FETs do the same job as the diodes for voltage backflow? They could. Yeah. You could use a FET in like a forward biased direction, use it kind of like as a semi-ideal diode type situation. But we don't need to. These diodes are small, they're relatively low forward voltage drop, and I think they will do the job. So, okay, I am going... Don S is here. So, Don, Crispian had a message for you just before we go. And so, yeah, anyway, Crispian's message was thank you. Okay, now I'm going to try ending this stream using the new stream setup. So in theory, what should happen when I press the button is it should kill my camera. It should switch to the video of like the exit thing with the thank you screen with the music. It should kill my mic, and then it should end the stream after a certain number of seconds. I don't know if this is going to work. I'm going to press the button. I may still be here. But just in case it does work, thank you very much for coming along. Happy Mother's Day to everybody that is relevant to. And I will see you. So next Sunday is the barbecue. Not today. Next Sunday is the barbecue. And please feel free to come along if you're in Melbourne. So I will talk to you all later. Thanks. Bye.